the open seminar of Venkata Ramana has been known. So he did his BSc and MSc from Andhra University, Visakhapatnam in 2000 2002 respectively. And then after a short stint at Center Pharmaceuticals in Baroda, and he joined my group here in 2003. And now he's ready to submit his thesis entitled Synthesis of Novel Polyhydroxylated Pyrrolidine and Change in the Sugar Habits as Glycosylated Pyrrolidine.
Thank you, sir, for your presentation. Good evening, everybody. The proposed title of my thesis is Synthesis of Novel Polyhydroxylated Pyrrolidine Cyclohexane and their Sugar Hybrids as Glycosylated Inhibitors. I have divided my thesis into 4 chapters. Chapter 1, Synthesis of new pyrrolidine-based single sugar as glycosylate inhibitor. Chapter 2, Synthesis of hybrids of D-glucose and D-galactose with pyrrolidine-based single sugar as glycosylate inhibitor. Chapter 3, seroselective synthesis of glucoquercetal plus galaquercetal and 5-amino-5-deoxy-D-glucoquercetal from D-mannitol. Chapter 4, the synthesis of novel hybrids of 3-deoxycarbopyramidase with pyramidase as glycosylate inhibitor. Chapter 1, Synthesis of new pyrrolidine-based single sugar as glycosylate inhibitor. This is glycosidic bond which joins the external functional group to the sugar molecule at anomeric center. Glycosidase is an enzyme which hydrolyzes the glycosidic bond, which also involves in a wide range of important biological processes. And glycosidase are also involved in wide variety of metabolic disorders such as influenza infections, cancer, AIDS, and diabetes. There are 2 ways to inhibit such processes. One is by making non-hydrolyzable G-glycosidic linkages, and another is by making enzyme inhibitors to inhibition of these enzymes. By replacing ring oxygen with NH in glucose is called nosuromycin. These are some naturally occurring nosuromycin and deoxynosuromycin, 1-deoxynosuromycin, and these are some pyrrolidine analogs. These are all naturally occurring glycosylase inhibitors which act as an enzyme inhibitor. These 2 molecules are synthetic analogs of 1-deoxynosuromycin and which are acting as glycosylase inhibitors. This N-butyl 1-deoxynosuromycin is useful in the treatment of Gaucher's disease, which is available in the market as a drug named Javasca, and this one is Miglitol. This is also another synthetic analog of 1-deoxynosuromycin. This is available in the market as a drug named Glycet, and which is useful in the treatment of type 2 diabetes. This is generally accepted mechanism for the glycosidic bond cleavage, and these 2 carboxyl groups of an enzymatic site are responsible for the specific cleavage of glycosidic bond, which involves a molecule of water here for the hydrolysis. And these 2 carboxylic groups of this enzymatic site are playing role as an acid and base catalyst, which involves an oxocarbenium ion transit state. These are some transit state analogs which will mimic the positive charge in the transit state. These are some pyrrolidine-based resin sugars. If you see, for the same type of skeleton, by changing the serial chemistry of hydroxyl group, changes the specificity towards enzymes. These are some biologically active polyhydroxylated molecules containing OH and CH2OH with the same carbon. For the past 2 decades, this Bailey-Silman reaction has got a close array of synthetic organic chemists due to having 3 functional groups in that adduct. Bailey-Silman reaction is reaction of acrylic acid with carbon electrophile in presence of a catalyst yield this trifunctionalized compound. Basway et al. Have done extensive work on this reaction. From our lab, we were also reported these transformations on Bailey-Silman adduct in this recent year. CAN and sodium nitrate mediated conversion of this Bailey-Silman estate to the corresponding beta-nitroacrylic acid, and also reduction of this Bailey-Silman estate the influence of palladium acetate and tricyclamine formic acid to yield this tri-substituted olefin. Further, from the daily filament, from this daily filament adduct, which is derived from the mannitol derived aldehyde, we synthesize this immunosugar, and the shaded part of the carbon skeleton is directly obtained from the daily filament adduct. And the regioselective amination and ring closing metathesis diastereoselective dihydroxylation are the key steps employed in the synthesis. Retrosynthetic analysis of our target molecule is as shown here, which illustrates the importance of regioselective amination and ring closing metathesis and diastereoselective dihydroxylation. Coming to the synthesis. This daily filament adduct can be easily obtained from this mannitol derived aldehyde on daily filament reaction with ethyl acrylate in presence of DAPCO, and which can be obtained from this D-mannitol. This daily filament acetate can be obtained from the simple acylation of this alcohol, and this tosyl amino compound can be obtained by the regioselective amination of this daily filament acetate with paratol sulfonamide and in presence of DAPCO. In detail, this is not a SN2 reaction. This is not an SN2 reaction. This is a successive SN2 prime reaction. First, DAPCO reacts with daily filament acetate to result this DAPCO salt of daily filament acetate, which again undergo SN2 prime reaction with this paratol sulfonamide to give this tosyl amino compound. Alynation of that tosyl amino compound under basic conditions with allyl bromide gave the corresponding to separable mixture of an allylated product. The more polar diastereomer obtained as a white crystalline solid, which was subjected to subsequent recrystallization from DCM and hexane, gave the crystals for X-ray crystal structure analysis. And this isomer is confirmed from that analysis having the stereocenter SS. With the optically active alpha beta unsaturated ester in hand, we did reduction with diol H at low temperature to yield this primary alcohol. Detosylation of this primary alcohol was carried out in sodium naphthalenide solution at low temperature, and further acetylation gave this diacetate. This olefin is now ready for the cyclization. We have subjected this olefin with Grubbs first generation catalyst, but we have observed no reaction even at reflection solvent. Then we went for high active ruthenium complex Grubbs second generation catalyst and subjected for RCM reaction. We obtained a single product pyrrolene skeleton in goodies. Dihydroxylation of this pyrrolidine skeleton gave this exclusively one diastereomer of diol. Here the diastereoselectivity can be explained by the acetylate group being bulky, it blocks the beta phase of this pyrrolidine skeleton, results in single isomer of diol. Further, decatalization of this acetylate group in presence of acid followed by acetylation gave this hexacetate in pure form, which was deprotected under strong acidic conditions, gave out one of the target molecules. Likewise, the other isomer of immunosugar was synthesized from the other RS diastereomer as similar steps shown in the earlier scheme. The enzyme inhibition activity of this immunosugar A and B were carried out against this commercially available glyphosate enzyme. And interestingly, immunosugar A showed specific inhibition against beta galactosidase at moderate concentration, but immunosugar B showed potent inhibition against alpha galactosidase and moderate inhibition against alpha mannose. Conclusions of my first chapter. We have developed an efficient method for the synthesis of immunosugar A and B from daily filament adducts containing masked diol Immunosugar A specifically showed good inhibition against beta galactose and immunosugar B showed no inhibition against alpha glucose, beta glucose, and beta galactose, but it showed good inhibition of alpha mannose and potent inhibition of alpha galactose at 100 micromolar concentration. Chapter 2. The synthesis of hybrids of D-glucose and D-galactose with pyrrolidine-based immunosugar as glycosase inhibitors. Hybrid systems, which are made up of different molecular entities. Hybrid molecules possess novel architecture and these have promising physical, chemical, and biological properties. Carbohydrates, peptides, steroids, and taxoids have been employed in the synthesis of hybrid molecules. Wang et al. Have synthesized this neomycin B mimetic, which is a hybrid of carbohydrate and peptide. This is carbohydrate part and this is peptide part. And this is a better inhibitor than the neomycin B. Nelson et al. Have adopted a building block approach for the synthesis of 1,5-beta-D galactopyronoside amino acid library. From that, they found that this particular hybrid molecule was found to good inhibitor of this beta galactose. T.J. et al. Have synthesized this hybrid of galactose and CQ analog of CC1065. This is the drug molecule, and they have proposed that this position was protected with sugar molecule such that it should be cleavable and selectively at tumor sites. Bleomycin is an excellent example of hybrid molecule, which has three different functional entities responsible for three different biological targets. Here the yellow-rich compound is responsible for metal binding and this carbohydrate domain is responsible for cell penetration and this thiazole is responsible for DNA binding. Mehta et al. Has synthesized this engineered carbon sugar and this particular engineered carbon sugar is showing was shown better inhibition than the parent carbon sugar. From our group, recently we have reported the synthesis of hybrid sugar, which are representing the hybrids of D-galactose and the noseromycin and its analog, which are found to show good selective alpha glycosylase inhibitor. And we were also, from our group, we have also reported the hybrid sugar, like hybrids of sugar and agar sugar bearing anomeric methoxy group, which are also found to good inhibition against enzymes. And we have also reported the hybrids of oxa carba sugar, and these are some other hybrids we have reported. These are representing the sugar and carb amino sugar hybrid. And we have also reported the hybrids of sugar with 3-deoxynoseromycin lactam and pyrrolidine. This MDL73945 was found to show a promising anti-diabetic activity, which is a disaccharide mimetic containing galactose derived hybrid for synthesis. Conclusion of second chapter. We have synthesized new class of glycosylase inhibitors, which are representing hybrids of D-glucose and D-galactose with pyrrolidine-based sugar. Enzyme inhibition studies of these compounds against various glycosidases show that these compounds were moderate and selective inhibitors of galactose. As we see here, these three molecules are showing only galactose active against galactose. Only three showing active against alpha glucose. It may be possible to improve the inhibition activity by appropriately changing the structural features of hybrid molecule B, as it is showing specific inhibition against alpha galactose. Chapter 3. Stereoselective synthesis of mucoquercetal plus galaquercetal and 5-amino-5-deoxy-D-lipoquercetal from D-mannitol. Quercetals are basically deoxyinositol. Inositals are you have hydroxy here, that is inositol. So quercetols are basically deoxyinositol. The family of quercetols is one of the all known largest family in the organic chemistry, which is having 16 diastereomers in its family, of which 4 are symmetric and 12 other isomers are being grouped in a 6 optical mirror images. Plus protoquercetal, minus protoquercetal and minus dibroquercetal are naturally occurring stereoisomers in its family. Many groups have synthesized in many approaches of this quercetal. Among them, Palsy et al. Have done extensive work on the synthesis of this quercetal, which are some of the syntheses are having parallel forms and some of the syntheses are having rhythmic synthesis. In this chapter, I have synthesized these 3 molecules: lipoquercetal, galaquercetal, and 5-5-deoxy-D-lipoquercetal. Retrosynthetic analysis of our 3 target molecules is as shown here, which illustrates the importance of this key starting material aldose and this ring-closing metathesis reaction. The key starting material aldose can be obtained from this D-mannitol as following reaction sequence: acetonization of mannitol and selective hydrolysis of terminal acetonide and reductive elimination of this hydroxyl group and further selective hydrolysis of terminal acetonide and subsequent cleavage of this diol in presence of this sodium paradate gave this aldehyde. That aldehyde was subjected to allylation under Barbier conditions. These are Barbier reaction conditions: zinc and ammonium chloride with allyl group. This obtained this diastereomer mixture of homoallyl alcohol. This decatalization of this acetonide group in presence of acid followed by acetylation gave this triacid as a separable mixture of diastereomers. The major diene was subjected to ring-closing metathesis by using rough first generation catalyst to get this cyclohexene derivative. Dihydroxylation of this cyclohexene derivative using acyl tetraxide and NMO gave the corresponding diol, and further acetylation gave the protected mucoquercetal. For further confirmation of this structure, we have esterified this to both hydroxyl groups with paranitro-benzyl chloride and pyridine, gave this diparanitro-benzoate, which was obtained as a crystalline solid, and its subsequent recrystallization gave crystals for the crystal structure analysis. From this structure, you can clearly see that this dihydroxylation has taken place opposite to the allyl ester group on the double bond. This cyclohexane derivative in one-pot reaction by using H2O2 and formic acid gave the diol, and which was isolated and characterized as its pentaestate upon acetylation. This is plus galaquercetal, and it is clear that epoxidation has taken place opposite